So in order to start talking about the unit circle, and this starts at day 1. And from here will be a little bit of recap of what we talked with special right triangles, which I've seen in the history of right triangles, especially special right triangles, it's kind of always a reteach. Don't think a lot of people keep this in their memory for a long time, like their address or their phone number. So with 4545, if you recall back in geometry, when you set this up, you said if each one of these were equal, they'll be the same because the angles are the same. And that means that the hypotenuse will be whatever the lengths of the legs are times the square root of 2. And so their ratio is kind of an x root 2. Which means that if you give me any value of x, I can plug it in and find the other parts of the sides, other lengths of the sides. When you come over and look at a 30, 60, 90, the 45 is a little bit easier. 30, 60, 90 a little bit harder, just because the values aren't just as easy. So with this one, the 30 degree angle will be x. Your 60 degree angle will be x root 3, and your hypotenuse will be 2x. Again, that means if I'm given any length side, I could solve for x and plug it into every other lengths of the side as well. This does away with having to use trig functions on your calculator. This has to do away with SOHCAHTOA. Has to do away with using even the Pythagorean theorem. All the idea is, hey, if you just give me one length, I can solve for x and find the other lengths. And even better, you're finding the lengths exactly, which means that the square root of 3 is exactly what the square root of 3 is. And you're like, well, that makes sense, duh. Well, in your calculator, guys, do the square root of 3 and tell me what you get. Reese, what'd you get? 1.73. And then stop there? Kept going. And actually, it's going to go on for infinity. So you're actually going to have to either round or truncate eventually, which means that is not the exact answer. The exact value of square root of 3 is square root of 3. Not the 1.73, because you're going to actually have to stop at some point. So with that being said, this is actually more precise than that. So we leave all our answers, guys, from now on is going to be in exact form, which means it's going to be the square root of 3 or square root of 2 or some type of square root, okay? So it goes on to problem number 1 and says, what is the value of A when the hypotenuse, which is the longest leg, is equal to 1? And they've drawn you a triangle over here. And they said, what if the leg is equal to 1? Well, back in the day when you did this in geometry, you said, okay, well, if I look at a 30, 60, 90 up above, we see the length of the hypotenuse is 2x. Well, in this particular problem, it is equal to 1. So we're going to set up an equation. Our reference leg, which is 2x, is equal to our problem, which is 1. So we need to solve for x here. So x is equal to 1/2. Which states, well, if x is equal to 1/2, go back up to our reference triangle. If x is equal to 1/2, what is the length of the side that is opposite of it? Exactly what x is. Because the length of the side across from 30 degrees is x. Well, did we not just solve for x? We now know that x is 1/2. So A, which is located across from 30 degrees, is 1/2. Well, for grins, let's just go ahead and say, what is going to be the length of the side across from 60 degrees? 1/2 times the square root of 3. Or if we're to write that a little bit better, root 3 over 2. Then we look at the next one. What if the hypotenuse, I don't know what you're doing, but you're not writing. So start writing. Thanks, Preston. So if the hypotenuse is equal to 1 on a 45-degree triangle, well, according to our reference triangle, what is the hypotenuse length equal to? X root 2, but in our problem it needs to be equal to 1. Same exact thing as we did before. Now, of course, what you've talked about in this is you can have a square root as a denominator. So you have to do what's called rationalizing it. So you multiply the top and bottom by whatever that square root is. This ends up being the square root of 4, which is also just 2. So, if x is equal to what we just found, square root of 2 over 2, what is the length of the side B? According to our reference, it is exactly what x is. It's kind of the same thing we did earlier, right? We solved for x, we found it, that gave us the length that was in question. So over here, square root of 2 over 2. And then, of course, the same is true on the bottom, but I ran out of space on mine, but you have some, so square root of 2 over 2. Special right triangles, 30, 60, 90, 45, 45, 90. As you notice, the only answers we are getting is root 3 over 2, 1/2, or root 2 over 2. Think about those three values for a second. And where are they at? Located on these triangles. Because now what we end up doing is, let's apply this if we have what's called a unit circle. Basically what a unit circle is, it's a circle that has the radius of 1. When you have the radius of 1, as you start to go around the circle, bless you, you have coordinates along that circle. If you think about it, if the circle is centralized at the origin, and you see the radius starts at its standard position and starts to go around, it creates this circle here that's written in red. There are coordinates all along this. And if you've talked about it in Algebra 2, hopefully a little bit, is when you look at a point on a graph, it's going to have an x component and a y component. You guys always know them as coordinates, x, comma, y. But what you can think about, and you guys even did in Algebra 1, basically was, some of you guys use a reference, step into the elevator to go up or down. Well, when you're plotting a point, let's say the point is 2, 3, you move over 2, and then you move up 3, right? And then that point right there is 2, 3, because you went to the right 2 and up 3. And so that's exactly what we're establishing here is, well, what if I was to find coordinates all along that circle? Well, the way to find it is, find its x component and its y component. Well, what you can do is here, create a triangle, and the first one's going to be 30 degrees. And from there, we established already that the radius is 1, which if we're going to go ahead and look at these points, look at the coordinates separately, this is the hypotenuse. So the hypotenuse is 1, and we're dealing with a 30, 60, 90 triangle. Well, we just did that on question number 1. So what was the length of the side opposite of 30 when we just solved? There you go. If you look in the previous page, you'll notice that the side opposite of 30, when the radius is 1, is 1/2. What's the side that's adjacent to 30? Square root of 3 over 2. Therefore, the coordinates of P is root 3, comma 1/2. And I think that's actually the question. That's number 3. Okay? So basically we're taking what we just talked about, that triangle, 30, 60, 90 triangle with a hypotenuse of 1, and put it on a graph. And now took those lengths of the legs and made them into coordinates now. And so you can see this. So I went over root 3 over 2, went up 1/2. So then it goes on and says, using trig ratios, SOHCAHTOA, let's find the sine of 30. So here's our triangle. Here's 30. Opposite's 1/2. Adjacent's root 3 over 2. And the hypotenuse is 1. What is sine? What over what? Opposite over hypotenuse. All right. Looking at this triangle, 30 degrees, and I kind of already said it, but what value is opposite? Which means this is adjacent, and that's the hypotenuse. So let's go ahead and write that into our problem to solve for the sine of 30 degrees. Opposite, you said, is 1/2. What's the length of the hypotenuse? 1. Clean it up, and you get the value of 1/2. What about cosine? That's the answer, but what over what? We'll take the same steps. We're going to get there, yes. A over h. Just like what Ali said, it's the square root of 3 over 2 divided by 1, which if you clean that up, now, what do you notice whenever we do trig functions with the unit triangle, with the unit circle? Right. Why is it that when we find these trig functions and I plug them in, they're not changing their values? Because what's 1? The hypotenuse is 1. That means, and we've learned that except for tangent, and we'll get to that later on, we've learned with SOHCAHTOA that it's always an opposite or adjacent divided by the hypotenuse. Do you all agree with that? It's always that type of scenario. It's always divided by the hypotenuse. Well, in a unit circle, guys, the hypotenuse will always be 1. So when you divide by 1, basically all you're going to do is, for sine, you're just going to look for what? What's the O represent? Okay, for cosine, what are you always going to look for? Adjacent. Let's talk about that, guys, dealing with this triangle in a coordinate. This triangle that's imposed or into a coordinate here, the angle we're always going to talk about, guys, is going to be the angle at the origin. Always. Okay? Because we just talked about it last class. You start on the positive x-axis, and you go that many degrees, which means it's degrees from here around, always in the origin. So, with that being said, 30 degrees, what is always going to be opposite of 30 degrees? 60 will be there, you're right, but I'm talking about the side length. 1/2, always. And the 1/2 will always be what value? Your vertical or your horizontal component? Vertical. If this is always 30 degrees here, it will always be the side opposite, which means it will always be the vertical component. Which sums up this way. What do you know about sine and cosine? Sine is the y-coordinate. And cosine is your x-coordinate. It'll always be true because cosine will always be adjacent, which will always be your x-coordinate. Sine will be your y, which will be opposite, which will always be there. That's even true when you're over here, guys. Because again, we're talking about this angle, but, and I'll get to it in just a moment, you're going to bring the idea of reference angles. Do y'all remember reference angles? What is reference angles again? How far it is from the angle. So if I have something like this, here, where do I draw my angle symbol to represent my reference angle? The left side. Right there. That is going to be my reference angle. It's always the angle, acute angle to the x-axis. Whether it's going down to the x-axis or up to it, it's always going to be the acute angle to the x-axis. And it'll always be positive. So with that being said, guess what? Another right triangle. This angle is always what we're talking about. This side will always be sine. This side will always be cosine. Same is true when we're dealing with this quadrant and that quadrant as well. It's always going to be the inner angle, which means that sine will always be your y value and cosine will always be your x value. Let's see some more examples when it's 60. So it goes on and says, looking at this angle, the interior on this one is 60. And of course, as we already established, what do you think is going to happen with the coordinates here, guys? The what? Close. They'll all be the same, but one thing's going to be different about them is what? They're switched. Exactly. What was 1/2 is now root 3 over 2. What was root 3 over 2 is now 1/2. Because we're looking at a different point of view. We're looking from the 60-degree angle mark. So the coordinates for R is going to look exactly like the coordinates of P, except they're going to be flipped. Oops, I think I put that in the wrong spot, but you get the idea. So with saying that, guys, and talking about our newfound information, what is going to be the sine of 60 degrees? Good. How'd you find that? Well, he says it's root 3 over 2 because 60 degrees, the opposite, the length that's opposite is root 3 over 2. And of course, we're only dividing by the hypotenuse, which we've already established the hypotenuse will always be 1. So basically, it's just going to be the length of the side opposite. What about the cosine of 60? 1/2. Again, same reason. Adjacent divided by the hypotenuse. The adjacent is 1/2 divided by 1. So it's just 1/2 is your answer there. And of course, again, what do you notice about the sine and cosine and the coordinate points? Sine, I'm going to write it again, is the y value, or y coordinate. Cosine is the x coordinate. Sine is y, cosine is x. (45). A little bit easier. So we have 45 degrees is here. We've already established that the length of both sides of a 45-degree triangle is what? What did we just do earlier? X, but we went ahead and said, what if the hypotenuse is equal to 1? What ended up being our new lengths of our side? There you go, root 2 over 2, root 2 over 2. Therefore, the coordinates of P both root 2 over 2 and root 2 over 2. The values of those two, what's the relationship? They're exactly the same. Can anybody tell me why that is? The angles are the same. What do you mean, the angles of what? That would explain why the lengths of the legs are the same. You're exactly right. But can you tell me why, when we're dealing with a unit circle, the coordinates are the same?
It's the same distance this way.
Okay, why is that? You're exactly right. You guys are saying you're so close. Just there's one thing I need to hear. Multiply by 1? Okay. Why would you think the coordinates of 45 degrees has the exact same x and y value? Okay, And I'll go ahead and finish that up, because you're exactly in the middle of the first quadrant. Right? If I go 45 degrees more, don't I get into, I'm done with the first quadrant? We're exactly in the middle of the first quadrant. 45 degrees is right in between 0 and 90. Do you all agree with that? Therefore, we are in the middle of the first quadrant, which means we have the exact same x and y values. And that will always be true for a 45 degree reference angle. So it'll always be true. So if I take this and go into the second, third, or fourth quadrant, I will still be getting negative root 2 over 2, comma, root 2 over 2. Now, there will be some sign changes because we're in different quadrants, right? If I'm in quadrant 3, what values, say it again, they're both negative. Did y'all follow me? Quadrant 4. So, we go over here. Sine of 45 is going to be root 2 over 2. Cosine of 45, root 2 over 2. And one thing you need to establish too is that the sine of 45 is equal to the cosine of 45. And then also, let me show you something else that we need to also establish. We didn't do it earlier. What do you notice about, you bet, what do you notice about the sum of 30 and 60? What does that add up to? 90. Which means this, the sine of 30 is equal to the cosine of 90. Which means that if you find two, what's that mean when two angles add up to 90? What's that called? Complementary. If you find two complementary angles, let's say 25 and 65, the sine of 25 is equal to the cosine of 65 because those two angles will add up. They're opposite. Okay? And that's why this works here, and vice versa as well. So then it goes on. What do you notice about the sine and cosine coordinate point? Again, it asks the question again, and we're going to answer it again. Cosine, x coordinate. Sine, y coordinates. Then at the end of it says, what is the relationship between sine, cosine, and coordinate point for an angle in a circle with a unit radius of 1? And we finish it off one last time. Sine of theta is equal to the y value. Is equal to the y value. There you go. Cosine of theta is equal to the x value. So if I'm able to, which we can now, because we know 30, 60, 90, and 45, I can find coordinates of any point around the unit circle in those reference angles. Now guys, mind you, we are only dealing with 30, 45, and 60. Those three angles. That is it. We won't be finding the sine and cosine of 72 degrees using this, or anything beyond those three. Okay? We're only going to be doing, well, I say those three, but we also have 0 and 90, and those will get easier. You'll see those. But 30, 45, 60 is the only things we're looking at right now. Okay? All right. Well, you're like, okay, that's great. Thanks for all this background information. Can we please put it all together? And we will. So, in just a minute, we have one more thing. So we go on and look at the unit circle and say, what about those 90, 180, 270? What happens when we're at the positive y-axis? Or we're at the negative y-axis? Well, we are talking about a unit circle, which I've already established earlier. The radius is equal to 1. So what is the coordinate of that point right there? 1 comma, there you go. What if I was to go at 90 degrees? What's the coordinate of that point? 0, 1. What about that point? Negative 1, 0. And then find the last one. Negative 0. I like that. And so there you go. when we land on the axis, when you land on the axes, you actually get coordinates that are nice and whole. -1, 0, +1, 0, 0, 1, 0, -1. Not this √2/2 or √3/2 or 1/2. You get those coordinates right there. So coordinate point B for 90 degrees is, we already established, 0, 1. For 180, -1, 0. 270, 0, -1. And then 360 or 0 degrees, guys. You should notate 0 degrees. 360 or 0 will give us the coordinates of 1, 0. And he goes on to say, all right, now that we know the relationship between sine and cosine and the coordinates, what is the cosine of 90 degrees? Well, cosine deals with what values again, guys? That's for trig, but we're past that. Say it again. Somebody said it over here. Yes. What is the x-coordinate? What is the x-coordinate of 90 degrees? 0. What is the y-coordinate of 90 degrees? So the sine of 90 degrees is 1. What is the x-coordinates of 180 degrees? -1. What is the y-coordinate of 180 degrees? 0. X-coordinate for 270.
0.
Y-coordinate for 270. X-coordinate for 360. All right, you'll get it. Questions about that, guys? That's actually, guys, how you find these values. Now, these are the easier ones because they're right on the axes. And all you're doing is saying, oh, what's the coordinate there? And we're good to go. And we have reference to look at. So let's go ahead and put this all together. And I apologize for how small this is. So do what you can. I just did these notes to make a key, and it was writing very small. So I get the luxury of zooming in. You guys don't, sorry. Actually, it's kind of funny. I've done this so often now. I looked at it, and a part of me want to instinctively take my paper and zoom in. Like, I just want to go ahead, but it didn't work. So first off, let's start in the bottom right here, and we'll say, okay, this is going to be 0 degrees or 360 degrees. Then we also talk about radians. Well, how many radians is 0 degrees? Say it louder. 0. How many radians is 360? Zero is where we started. Takes us 2 pi to get us completely around. We already established what is the coordinates here at this point. And like I said, we're only going to be dealing with 30, 45, or 60 in this matter. So the next angle up is going to be 30. Or what's 30 degrees in radians? 5/6. Using the triangles that we put together earlier, what is the x-coordinate of 30 degrees? Some flips of the pages and you'll get your answer. What is the x-coordinate? Should be the first problem we did on the triangles in a circle situation. Good. √3 over 2. What was the y-coordinate? 1/2. We've done 30 degrees. Let's move up to the next one, which is going to be 45 degrees. Or written in radians is what? Power over 4. This one's the easier one, guys. Because it's 45 degrees, what did we notice about the x and y coordinates earlier? And what were those values? Resuming on notes. All right, so we've done 45 degrees. Now let's move up to the next one, which is going to be 60 degrees, which is what, Morgan, in radians? Thanks. Okay, good. I looked quickly. I thought she had a Reedy High School shirt on. I was about to send you out. But. All right, so we have, and we established in earlier too, with the 30 degrees, how it looks on coordinates. What does that transfer to when we go to 60 degrees? They just flip, exactly. So we'll just go ahead and do that. And then we'll finish up with the very... Now here's the deal, is we are talking about quadrant 1, guys. I do have to establish this too, and you guys saw that in last class as well. If we land on an axis, we're not in a quadrant. Okay, we're on the line. So this finishes it. That finishes quadrant 1. And of course we got to talk about 90 degrees, which will be what in radians? Pi over 2. And of course, what's the coordinates for 90 degrees? 0, 1. Let's finish off the last thing, which we were discussing earlier, is in quadrant 1, what values are positive? Both of them, right? X and y. Which means what trig functions are positive in the first quadrant? Sine and cosine. So we're going to go ahead and... Negative? None. There are no trig functions that are negative in the first quadrant. All right. So we have this information here. We finished the first quadrant. Okay? And basically when we talked about, let's go back to what reference angles are again. What's the definition of reference angles? What's the two things we talked about? First is acute to the x-axis. Last one, always positive. Acute to the x-axis, and it's always positive. Well, let's take away the always positive part and focus on the one thing, acute to the x-axis. Would you agree every angle in the first quadrant is its reference angle? Would you agree with that statement? Every angle in the first quadrant, so if I went up 30 degrees, what is my acute angle to get back down to the x-axis? The exact distance I went up, 30 degrees. So that means everything in the first quadrant is going to be its own reference angle. And I bring this up because of this. If we look at a unit circle here, guys, just have to do some changes for just a second. So we've already established what first quadrant is. Then we go over and start saying, okay, well, let's go into the second quadrant. If you look at the second quadrant, you'll notice, and we're going to use these angles here. So we've already got all the way around. We got to 90. The next angle is going to be, well, it's going to be 30 degrees more. So what's 30 degrees more than 90? And so we did what? We did 30, 45. What's 45 degrees more than 90? 135. 30, 45, 60 is the last one we did. What's 60 degrees more than 90? 150. Okay, let's take those angles now. And let's go ahead and write out underneath them their reference angles. So what is the reference angle of 150 degrees? Which means, how many more degrees do I need to go to get to 180? What about 135? about 120? Just because I want to make this complete, guys, and we have time to do this, I'm going to go ahead and write out. I am going to move the stuff we just did above. Let's move it into the first quadrant here. Yes, it means you have to write it again. Sorry, but I want to see a completed unit circle for our notes today. Okay? So we'll just go ahead and rewrite everything we did. Whoa. So I went ahead and moved everything from what we just did into the first quadrant. And now, notice what we put in red. Does it look like it's a mirror image over the y-axis? And it should. It's reflected about the y-axis. So what do you think, at 150 degrees, what do you think the y-coordinate is going to be? If it's exact reflection of it. You're right. I did the y-coordinate first because there's something different about the x-coordinate. What do you think that is? It's negative. It is the negative version of what we have in the first quadrant. We are picking these coordinates. We're taking the red number and making that degree, the red degree, and we're matching it with the coordinates in the first quadrant. And we're paying attention to where we're located on the coordinate plane. So what is going to be the coordinates for 135 degrees? Common of positive, square root of 2 over 2. It's a duplicate of it, except now we're just adding negatives for all the x values, aren't we? So that means that 120 ends up being negative 1/2, comma, root 3 over 2. I'm not going to do this. We're not going to do 120 by hand and convert it. Just for grins, what was radians? What was radians of 60 degrees? Whoops. I'm going to take that, and you notice the pi has moved over a little bit. I'm going to take the denominator and subtract 1. 120 degrees is 2 pi over 3. You can check if you want. It is. 45 was what? Pi over 4. You subtract 1. $30 degrees was pi over 6. You subtract 1. You've been gone for a while. You missed some good stuff. So what you notice, guys, is the radians here, and there's a lot. I know there's a lot to take today, a lot. That's why the notes are almost going to be done after we finish this unit. But the idea is you can see where the coordinates are, you can come up with them, and then from there we can easily just say, what's the sine of 45 degrees? Well, sine deals with what values, guys? Sine deals with what values?
Y.
Y values. So what is the y value at 45 degrees? What is the y value at 45 degrees? RC, do you know what the y value is at 45 So y'all know the answers, you're just not saying. Is that what it is? You all know it. You just, no one wants to say anything.
Well, we don't know for.
Are we waiting for Trent to say something every time? Because Trent will. Trent always answers. That's one thing that Miss Blanton's always saying, is that Trent, he'll always answer the question. It's like, yes, he always does. I like it. There's nothing wrong with it. I'm actually glad he does.
I answer too.
You do too. I know. I was going to say something about it, but you beat me to it. No, you better not, or else we're just going to be here waiting. I'll start calling some names out. Pretty sure no one wants that. All right. So we finished off the second quadrant with, we're back to the x-axis. Unfortunately, we're on the other side of the x-axis, right? So you look at it, we're at pi, which is a half a circle, and it's 180 degrees. And then we go ahead and put the coordinates there like we established earlier.
Coach,
Yes, sir.
on the top one where it says 60 degrees, should that be 30 or no?
The red 60?
Yeah.
No, this one should be, now, Trent, the distance from here to here is 30 degrees. But you got to remember, 60 represents the distance from down to the x-axis. That's a good question to ask. Because, yes, the distance from 90 to 60, that red 60, is 30 degrees. But remember, the red represents reference angles. The red represents reference angles. So if we go ahead now, guys, we're starting with 180 at the x-axis. We're going to go down now into the third quadrant. Oh, before we leave the second quadrant, let's go ahead and write out what values cosine or sine is positive in the second quadrant. Where are we at? What values, how about this? Let me go ahead with this. What values are positive in the second quadrant? You guys have answered now. It's sine. Because its y values are positive. Therefore, sine is positive and cosine is negative. Because we are on the second quadrant, which means all the x values are negative. And all the y values are positive. Guys, I know it's a lot. If it makes you feel better, this will be the fourth time I fill this in. If it makes you feel a little bit better. I'm going through this with you guys. I have to do it 4 times. So there we go. And trust me, as I'm doing notes for keys, I'm like, why am I doing this? I'm about to do it all over again with the class. I'm about to fill it all in. It's all the same thing, but I just got to fill it in. I have to do it anyway, so. All right. So, and some of y'all come back. It's your job. You have to do it, and that's fine. You're right. So we're at this first section here. And again, we're using the gaps that we've always talked about. 30, 45, 60. 30, 45, 60. They'll always be the same, guys. So what's 30 degrees more than 180? 210. Oh, let's go ahead and do that. You're going to roll. 225 and 240. Good. Let's talk about the radians real quick. Before we do that, though, let me go ahead and establish this real quick. What is the reference angle of 210?
30.
Reference angle, you're right. What's the reference angle of 225? And again, the last one. And it's interesting because you found those values of those angles by using 30, 45, 60. You said 180 plus 30, 180 plus 45, 180 plus 60, and those gave you that distance there. So that's the reason why you can come up with those reference angles pretty quickly. Well, what is 30 degrees in radians again, guys? Pi over 6. And now I'm going to plus 1. Take the denominator and add 1. What is the radian? What's 45 degrees in radians? Plus 1 to get your numerator. Last one was what? There you go. You got the idea. If you notice, guys, 30 is always with 60, 3 is always with 60, 4 is with 45, 6 is always with 30. We did that earlier, the activity we did where I had you guys doing classwork. And we were talking about what's the reference angle of 60? What's the reference angle of 405 degrees? And you guys said, oh yeah, it's pi over 4. Or what was the reference angle for all those types of radians that were given to you? So we can find all those, and it's just as simple as filling in, well, what's the number that goes next to it? Depends what quadrant you're in. And we'll get to that later on. We talk about that trick later on. All right, so let's do this, guys. Look at the red again. 30 degrees. What are the coordinates for 30 degrees, guys? We'll deal with the signs later. What's the coordinates for it? Root 3 over 2, 1/2. What is the coordinates of 45 degrees?
Root 2 over 2.
Repeat, right? Coordinates for 60 degrees? Okay. We're not quite done, I know, because you're like, well, all those answers are positive, and we are located where? Everything's negative here, right? Negative Nancyville. So everything's negative here, right? So therefore, all these x values are what?
Negative.
Everything. X value is negative and y value is negative. So just start writing a bunch of negative signs. And like you just said, everything's negative here. Sine and cosine are negative, and there's nothing positive, and I put ... yet. When we get to tangent, we'll talk about tangent. But for now, all we know is sine and cosine. So, what? We'll get to tangent in a moment. Yeah.
Is it easy?
The way I show you it is. I'm not bragging, I'm just honest. So. All right, so let's go ahead and finish off quadrant 3, guys. This actually ends up being 270 degrees. This is why when students sign up for pre-cal, they're like the unit circle and they cringe. Okay? I'm trying to think of what I can compare it to if any other math things you have. Oh, proofs in geometry. Proofs in geometry are hard because you have to find what you're doing. Like you have to find yourself through a maze. Okay? Unit circle is hard because you think, and a lot of people in the past have done it incorrectly because they think they have to memorize all of this. When we get done, they memorize all of this, which I think is ridiculous. I don't memorize this. This is all and I've done it 1,000 times. And I'll show you how in just a moment. So, over here, this is 3 pi over 2 is 270. And of course, we're looking at the coordinate here, and it's right on the axis, so it's 0 and 1. Talked for 48 minutes? Oh my gosh. All right, got to keep going. I'm going to finish this up. So again, taking our distances that we talked about, 30, 45, 60. Let's go ahead and start with 270 now and go 30 degrees, which gives us what? 300. 315. And 330. And of course, let's go ahead real quick, guys. Now, we are going to go ahead and fill in the reference angles right now. And recall, acute angle to where? The x-axis. Not back down to here, guys. This is a very common mistake. I've seen students come here and say, oh, it's 30 degrees because it's back down here. No, you always got to go to the x-axis. Even in this fourth quadrant as well, they always want to go back to 270. How many more degrees, guys, do I have to go in order to get to 360 if I'm at 300? There you go. You guys know the pattern. I'll let you fill it in. It's all the same. Radians of 60 is what again? 5 over 3. This one's a little bit, I know it'd be nice, wouldn't it? I really wish it was. Unfortunately, this trick is you have to double the denominator and subtract 1. And I don't want to go over that right now. I'm just going to fill these in. Trust me. Fill them in to get through them. How's that? I think technically if I was supposed to do what we're supposed to, I think I had you guys supposed to be converting them all along the way, but I don't have time for that. So here we go. And Allie doesn't either. She's got things to do. So what is the x and y coordinates of 60 degrees, guys?
1/2 over negative square root of 2.
He's already saying... Trent's already putting the negatives in there. And that's fine. Because what values are negative here, guys? Y values. Which sign? Guys, go ahead and finish off the rest. Make sure I did that right. And that completes a unit circle. I guess one thing I did not do, if we want to do it all the way. All right, so